Why the very question about a Boeing 787 freighter is already wrong. Take a look at the Boeing 787 Dreamliner, one of the most technologically advanced aircraft ever built. A composite fuselage, digital systems, exceptional fuel efficiency, and long range. An airplane that fundamentally changed long-haul passenger aviation. And precisely because of that, a seemingly logical question arises. If the 787 is so efficient, why hasn't it been turned into a freighter? Why don't FedEx, UPS, or DHL operate the 787 for cargo? Why do we see freighter versions of the 767, 757, and A330, but not the 787? At first glance, the answer seems obvious. Perhaps the aircraft is still too young. Maybe Boeing simply hasn't had time to develop a cargo variant, or perhaps the market isn't ready yet. But all of these answers are wrong. The issue isn't the age of the aircraft. It's not a lack of demand, and it's not even a strategic decision delayed by Boeing. In reality, the question itself, why the 787 never became a freighter, is based on a flawed assumption about how aircraft are designed and how aviation economics actually work. Aviation history has conditioned us to expect one simple pattern. A successful passenger aircraft eventually becomes a cargo aircraft. That's what happened with the Boeing 747, with the 767, with the 737, and even with narrow-body aircraft like the 737. When a passenger aircraft reaches the end of its airline career, it gets a second life. The windows are sealed. The seats are removed. Cargo containers take their place, and the aircraft continues generating revenue for decades. So it seems reasonable to expect the same from the 787. But the Boeing 787 is not just another passenger aircraft. It was designed around a fundamentally different philosophy. To understand that, we need to go back to the early 2000s. At the time, the aviation industry faced a serious challenge. Fuel prices were rising. Passengers wanted to fly farther and more frequently. Airlines were looking for ways to open direct routes between city pairs that couldn't economically support large wide-body aircraft. Boeing saw an opportunity, and instead of focusing on size, it focused on efficiency. The 787 was not conceived as a flexible, multi-role platform. It was designed as a precision tool for a specific mission, to carry passengers over long distances using as little fuel as possible, while maximizing comfort and minimizing structural weight. Every major engineering decision on the 787 served that single objective. The composite fuselage reduced weight. Higher cabin pressurization improved passenger comfort. Larger windows enhanced the onboard experience. Electric systems replaced traditional pneumatic ones, reducing fuel burn. But there's a critical detail hidden within that philosophy. None of these decisions were made with a future freighter version in mind. Boeing did not design the 787 as an aircraft with a second career. It designed it as a highly optimized passenger machine, where every kilogram, every structural element, and every load case was calculated for a very specific operational profile. And this is where the conflict with cargo operations begins. Passenger aviation and cargo aviation may look similar from the outside, but in practice, they are two very different worlds. Cargo aircraft don't need windows. They don't need comfort. They need simplicity, structural robustness, and the ability to handle repeated concentrated loads from heavy cargo containers. Historically, that's why freighter aircraft were either built from aluminum airframes or designed from the outset to tolerate harsh operating conditions. The 787, by contrast, was designed as the opposite of that logic. It was built to be lightweight, tightly pressurized, and optimized for passenger loads, not for heavy, concentrated cargo on the main deck. And while, from a purely technical standpoint, almost any aircraft can be converted into a freighter, aviation has never been about what is technically possible. It's about what makes economic sense. In the case of the Boeing 787, that question was effectively answered during the design phase. That's why, to understand why the Dreamliner never received a freighter variant, we need to stop looking at the cargo market and start looking at the aircraft's engineering DNA. In the next part, we'll examine why the 787's design makes a cargo conversion not just difficult, but economically unjustifiable. Why the Boeing 787's design works against a freighter version. When people think about cargo aircraft, the process is often imagined as relatively simple. Take a passenger jet, remove the seats, reinforce the floor, cut in a large cargo door, and the aircraft is ready for service. In reality, it's far more complex. A cargo aircraft is subjected to fundamentally different loads than a passenger aircraft. Passengers are distributed relatively evenly throughout the cabin. Cargo is not. Containers create concentrated load points, especially on the main deck. Each of these loads is transferred through the floor, the frames, and the fuselage structure. And this is where the Boeing 787's design begins to work against the very idea of a freighter variant. One of the key differences between the 787 and previous generations of aircraft is its fuselage. More than 50% of the structure is made from composite materials, primarily carbon fiber. This allowed Boeing to significantly reduce weight and improve corrosion resistance. For a passenger aircraft, this is a major advantage. For a cargo aircraft, however, it becomes a challenge. An aluminum fuselage can be reinforced relatively easily. Metal handles localized loads well. It deforms in predictable ways and is easier to repair and certify after structural modifications. Composites behave differently. They perform exceptionally well under the loads they were designed for, but they are far less tolerant of deviations from those original design assumptions. Cutting a large cargo door into a composite fuselage requires extensive reinforcement of the surrounding structure. This is not a localized modification. It effectively means redesigning a significant portion of the aircraft. There is also the issue of the main deck itself. On a freighter, the main deck is a working environment. It must withstand thousands of loading and unloading cycles, involving heavy cargo containers. The floor experiences repeated impact and point loads that simply do not exist in passenger operations. The 787's floor structure is optimized for passenger seats, baggage, and distributed loads. Adapting it for cargo would require substantial reinforcement, which inevitably adds weight. And weight is the primary enemy of the very efficiency the 787 was designed to achieve. There is another important factor: pressurization. The 787 is designed to operate at a higher cabin pressure than previous generations of aircraft. This improves passenger comfort, reduces fatigue, and is one of the Dreamliner's defining features. Cargo aircraft operate differently. They do not require high levels of pressurization on the main deck. In fact, cargo doors, fire suppression systems, and the operational realities of freighter aircraft complicate maintaining such pressure levels. Any changes to the pressurization system once again introduce significant engineering trade-offs and additional structural reinforcement. Then there is certification. Any major structural modification requires new fatigue, strength, and life cycle analyses. For composite aircraft, this process is particularly complex and expensive. Regulators demand extensive proof that the modified structure can safely operate for decades. For aluminum aircraft, these certification pathways are well established. For wide-body composite freighters, there are very few real-world precedents. As a result, engineering costs, testing requirements, and certification expenses escalate rapidly. And this leads to the central paradox. To turn the Boeing 787 into a freighter, it would need to be reinforced and modified so extensively that it would no longer be the aircraft airlines value today. It would become heavier, less efficient, more expensive to maintain, and more complex to repair. In effect, every core technology that makes the Dreamliner an exceptional passenger aircraft simultaneously works against its transformation into an efficient cargo aircraft. That's why the real question is not whether the Boeing 787 can technically be converted into a freighter. The question is why anyone would want to. In the next part, we'll look at the economics and the market and explain why, even with the technology and the capital available, a 787 freighter makes little sense for operators or for Boeing itself. The economics that ultimately make a 787 freighter unnecessary. By the time we reach this point, the picture becomes much clearer. The absence of a Boeing 787 freighter is not the result of hesitation, missed opportunity, or a lack of imagination. It is the result of economics quietly overruling engineering ambition. In commercial aviation, Technical feasibility is only the starting point. What ultimately matters is whether an aircraft can perform a specific mission better, or at least more profitably, than the alternatives. And this is where the 787 runs into its final and most decisive obstacle. Cargo operators do not buy aircraft to showcase technology. They buy them to move a very specific amount of payload over a very specific distance at the lowest possible cost per ton mile. In that context, the 787 occupies an awkward position. It is too advanced and too expensive for the role cargo airlines would ask it to perform. Developing a dedicated 787 freighter would require Boeing to invest billions of dollars in engineering, certification, and production changes. That investment would then need to be recovered through aircraft sales. But here's the problem. The cargo market does not need a next-generation composite widebody in this size category. For medium to long-range cargo missions, operators already have proven lower-risk options. The Boeing 767 freighter remains one of the most successful cargo aircraft ever built. The 777 freighter dominates high-density long-haul routes. Airbus covers similar segments with the A330 and A350 families. Each of these aircraft fits neatly into an existing operational and economic niche. A 787 freighter, by contrast, would sit uncomfortably between them. It would be more expensive than a 767 to acquire and operate. It would offer less payload capacity than a 777, and it would provide no decisive advantage that justifies its higher complexity and cost. From an operator's perspective, the question becomes simple. Why pay more for an aircraft that does not fundamentally change the mission? This is especially true when we consider fleet economics. Cargo airlines value commonality, shared pilot pools, shared maintenance procedures, shared spare parts inventories. Introducing a 787 freighter would add an entirely new aircraft type into fleets that are already optimized around existing platforms. That complexity carries real, measurable costs. There is also the issue of timing. Most passenger 787s are still relatively young. They're doing exactly what they were designed to do, flying long-haul, passenger routes efficiently. There is no large wave of retired airframes waiting to be converted as there was with earlier aircraft generations. Without a steady supply of low-cost used aircraft, the economics of passenger-to-freighter conversion simply don't work. And Boeing understands this. For Boeing, launching a 787 freighter would mean competing against its own products. Every 787 freighter sold could potentially replace a 767 or 777 freighter sale. That kind of internal competition only makes sense if the new aircraft clearly expands the market. In this case, it doesn't. Instead, Boeing has chosen to let the 787 remain what it was always meant to be, a highly specialized passenger aircraft, optimized for efficiency, range, and comfort, not versatility. And this brings us to the final insight. The reason the Boeing 787 never became a freighter is not because it failed. It's because it succeeded. It succeeded so completely at its intended mission that turning it into something else would strip away the very qualities that made it valuable in the first place. In aviation, the best aircraft are not the ones that can do everything. They are the ones that do exactly what they were designed to do, exceptionally well. And in the case of the Boeing 787, that mission has never been about moving cargo.